Hi, good day. So I'm going to explain to you how you perform task scheduling specifically for earliest deadline first priority assignments. So a typical question you would see about for task scheduling is something like this. You're giving certain information about the particular task. You're giving the period that a particular task is. You see here we have four different tasks. You're giving the periods, you're giving their worst case execution time, you're giving their deadline, and you're giving their initial delay. Now, all this information will be used to properly schedule the task. Okay, let's get started. So, there's a few things you need to do to get started with this question. And the first thing you need to do is to know how to calculate the priority time or priority value. So you're probably familiar with something that is like tau. And so the priority value for earliest deadline first priority assignment is given as this formula: 1 divided by your initial deadline plus a k value, which is just an arbitrary constant, multiplied by the period plus the deadline for that particular task. So this is the formula you need. Okay, so now let's calculate the priority times, because this priority times will help us plot a correct timing diagram for how you would schedule these assignments. Okay, so let's just do let's do 1 0 1 1 1 2 1 3, and we are doing this. So for this is all for k equal to 1 values, this is for k equal to 2 values, and k equal to 3 values, and also k equal to 4 values. Okay, so this is 2 0 2 1. For the sake of time, I'm just going to run through the first one. Okay, so for the first one, you could do this calculation in your head or do it on a scrap paper beside you there. So for the first one, you have k equal to 1, you have p1 equal to, you look at the task here, p1 is equal to 20. So p1 equal to 20, your v1 is equal to 16 over here. Then by the time you do the calculation for, oh sorry, this is for k0, sorry, for k1, yeah, sorry, for k0 is the first one we are doing, and this is all for the first task. So this is 1 0, and your priority assignment or your priority value would be 0, plus also your initial delay for the first task is 0. So this would be equal to 0 times 20 plus 16. Now this would all equal to 16. So this is basically how you calculate it. Let's do another example. Let's say you're looking for 2 1, your k is equal to 1, your p2 is equal to, this is your p2 over here, 40, your d2 is equal to, your d2 value is 32 over here, 32, and your initial deadline for the second task is also equal to 0. When you calculate your priority value, you would have 0 plus 140 plus 32, and you're left with 1 over 72. So I'm just going to run through this example. I'm just going to run through all the calculations and I'll be right back. Okay, by the time you're done with your calculations, you should have something that looks like this. So we are moving to the next step on EDF task scheduling. Okay, so the next step is we want to find out, first of all, what the LCM is. And a good rule of thumb is, for the most part, the LCM is usually the largest period here. So you just write the largest period now. What this LCM tells us is what exactly is the entire period of this task. We want to plot all of them on a period diagram. What is going to be the smallest? The smallest is going to be 0, and the largest is going to be whatever your LCM is. A good rule of thumb is to pick an LCM that is the same thing as the largest period for a particular task that is given. In this case, the largest period here is 80, so that is going to be our LCM. Okay, so the next step is to draw our timing diagram. I mean, there's a bunch of different names that it's called, but I like to call it the timing diagram because it's a diagram that plots out all the different tasks together. Okay, so our diagram looks something like this. We have 80 over here, and we have 0. So our it's going from 0 to 80. This is what the timing diagram looks like. Okay, the next step we are going to look at is how do you correctly identify all the different tasks period on this timing diagram. So for now, we want to look at the period. So the period for each of the individual tasks tells us how many intervals of that particular task are going to exist, right? For instance, you see T1 has a period of 20. T1 has a period of 20. It tells us that every 20 clock cycles, so every 20 time cycles, whatever you want to call it, T1 is going to be either preempted, or T1 is going to start up its what do they call it? It's is going to start up every single 20 every 20 clock cycles. That's what it's trying to tell us here. Okay, so now an easy way I like to visualize it is to just put, so at t equal to 20, so this is small t over here, this is small t, so this is small t. At t equal to 20, we know we have a particular task T1 that is preempted here. Now at another 20 intervals, t equal to 40, you have another one here. At another interval, t equal to 40, you have another one here. Sorry, I think my spacing is a little off. This is 60. And then if you were to do this, and then at another interval of 20, we have T1 preempted here again. This is 80. I remember this is T. Okay, so this is what your timing diagram should look like so far. We've plotted everything for T1. I'm just going to put T1 here. T1, T1, and T1. Okay, so the second period we are looking at is the period for task 2. We are saying that the period for task 2 is 40, meaning at every 40 intervals within that, at every 40 intervals within the domain of this, or within the range of this timing diagram we are drawing here, T2 has a place somewhere here. So T2 at 40, at 80, this is the second interval, you have T1 and you have T2. So this is what your diagram should be looking like so far. And you basically just repeat it for all the other ones. T3 has the exact same period as T2. So we're just going to put T2, T3 somewhere here. T3, and it has the exact same period, so it's also going to come up here. Then you have T3 over here, but T4 has a period of 80. So in this timeline from 0 to 80, it's only going to pop up just once here, and I'll tell you why in a sec. This is T4. So this is what your diagram looks like so far. But this is not everything. Also know that because our what do they call it? Because our task, or our preemptive task, have an initial delay of 0. That is this column here. Because everything has an initial delay of 0. It's telling us that at time equal to 0, every single one of those tasks are preempted. basically at the start of that timeline, whatever timeline it is we are looking at, 0 to 80, every single task is preempted at that timeline. So remember how we did it for all these. We're just going to put T1 here, T2, T3, T4. Now, if the initial delay was, let's say the initial delay here was 20, our task is not going to start from 20. Our task scheduling would, let's say if it's 20, our task scheduling will start from here. So then you're counting from 20 to 40 to 60 to 80. But our delay is initially 0. So everything is starting up at the same time at time equal to 0. Okay, so now you've drawn this. This is what your diagram should look like so far. The next step is to write out what your priority levels are. From the ones we've calculated up here, just start plotting it now. Note that this is k equal to 0, k equal to 1, k equal to 2, k equal to 3. Oh, sorry, I think I made a mistake. Sorry, this is this is k equal to 0, this is k equal to 1, k equal to 2, k equal to 3, and k equal to 4. So yeah, this was where I made the mistake. Okay, so you have k equal to 0, k equal to 1, and k equal to 4. So now at k equal to 0, which is the first row here, this is k equal to 2, sorry, this k equal to 1, k equal to 2, k equal to 3, k equal to 4. At k equal to 0, T1 has the priority of 1 over 16. T2 has a priority, which is this, of 1 over 32. T3 has a priority of 1 over 35. And T4 has a priority of 1 over 70. Now, at k equal to 1, your priority for T1 is 1 over 36. We see that there is no priority there. There is no priority there right now for the other one. Yeah, so at k equal to 2, T1 is 1 over 56. And the next one is 1 over 72. The next one is 1 over 75. This is 1 over 76. And at the last one, 1 over 96, 1 over 112, 1 over 115, and 1 over 150. So by the time you look at it, you actually don't need these calculations you did here. But I would just say, rule of thumb, just do all the calculations just so you, even if you don't need it, you still have it if you're plotting anything past 80. So I would say this is what it looks like so far. Now, depending on what your timeline is, if your timeline is, let's say, 200, you might need the other priority values. But if not, I would say just write everything down just so it's easier for you to visualize it. Okay, so now let us start plotting everything on this timeline. Okay, so now remember, it is earliest deadline first. So we are looking at the priority values that we've calculated. Don't look at these values. Don't look at these values right now. Don't look at this. Oh, we are going to look at this. But we are focusing on the CI values, which is the worst execution time. Worst case execution time. That's what we are looking at. It basically tells us how long it takes for each of those tasks to be executed. This one, for instance, is telling you that for every task T1, it's going to take it 4 period or 4 clock cycles, whatever you call it, for task T1 to be executed every single time. For it to completely execute itself, it's going to take it 4 cycles. So that's just the meaning there. Okay, so now let's start plotting. So remember I said that because the initial delay is 0, all the tasks are executing from 0. Even if the initial delay was 20, all the tasks are going to start executing from 20. But in this case, it's 0, so all the tasks are going to start executing from 0. So now, we're going to focus on what our priority levels are. Remember, the one with the lowest priority level comes last, right? The higher the priority, the higher the number, the higher the priority level. For instance, 1 over 70 is less than 1 over 16. Hence, 1 over 16 has a higher priority level. That's just an easier way of visualizing it. Okay, so the highest priority level here is T1. So we're going to start executing T1. T1 it takes 4 periods or 4 clock cycles, whatever you want to call it, for T1 to be executed. So we're just going to do 4 here. Let's assume this is 4. Sorry, my diagram is not drawn to scale, but this is T1 here. Okay, so now the next one with the highest priority level is T2, right? So T2 takes 4 it takes 4 periods for T2 to be executed, so kind of the same thing. T2. Okay, so the next priority here is T3, but we are noticing something about T3. T3 has 12 periods. That's perfect. 12 plus 8 equal to 20. So this entire clock cycle has finished with T3. This entire period has finished with T3. Now, logically speaking, we are done with the first block of, or do you want to call it clock cycle, whichever one you want to call it, we are done with the first one. So now, we're going to look at the next priority level. So we left off at 1 over 35. The next one in the priority queue is, now logically you could say the next one is T4, since it has started executing from the start, because logically you would say, let us finish executing the ones that we started with before we move to the next period block, right? But for earliest deadline first, note that we really don't care whether we are starting with T4 or we are starting with T5. We don't care. What we care about is, what is the priority level? If it has a higher priority level, it is going to push the previous one from the queue and is going to execute itself. That is the whole concept of earliest deadline first. It's basically going to just push you aside and get itself executed. So now, another kind of like way you could see it is that T1 has a period of 20. So no matter what you do, when you get to the period 20, T1 should be the one getting executed. The same thing, when you get to 40, T2 or T3 should be executed. When you get to 80, T4 has to be executed. That's another way to look at it. So let's start executing T1. Okay, but now notice that from the priorities that we have here and the periods that we have here, we only have one task that is available to be executed right now. So what do we do? Now, in a typical case, we're going to leave this as idle and move to the next period. But remember, we still have T4 that we started executing. The only reason why we did not continue executing T4 is because T1 has a period of 20. It also has a higher priority level. So we basically push T4 away to execute T1. So now that T4 that we pushed away, we are bringing it back to execute it before we move to the next priority. I hope this makes sense. So now T4 has a priority of, so T4 has a period of 24. So basically the entire code block, T4. But now, we know the entire code block here is actually, so 4 minus 20, that is 16. But T4 has a period of 24. Like for T4 to be executed completely, it takes 24 periods. But now, we only have space for 16, meaning we have 8 periods left. We have 8 periods left somewhere. Now, remember the reason why we halted the execution of T4 is because that is the entire code block right now. Okay, so let's move to the next priority. We are done with T4. We are done with the entire first code block. The next priority here is T1 because it's the one with the highest priority there. So T1 is executed. T1. And then you have, this is 44 over here. But now remember, we said we don't care which one came first. If we push something out of the way to execute something else because of a higher priority level, after we finish executing the one with the higher priority level, we still go back and recall the one that had not finished executing. It's called preempting. When you preempt, when you preempt something, you're basically halting its execution at a specific period, whether it is because the one that you want to execute now has a higher priority, or because that is the period of that one. We are halting execution. Hence, we preempted T4 at that point. So now, if you compare the priority level of T4 and T2 here, right? That's the next priority here. If you compare these two priority levels, you see that T4 actually has a higher priority level than T2. So logically speaking, you would execute T4 that had already been preempted. When you think of preemption, think of, I halted him before, I'm executing a higher priority level, so I'm going to go back after executing that priority level and then execute the one that was halted. So now we're going to execute 8 periods of T4. So you should be left with something like this, 52, right? So now we are moving to the next priority level. We are done executing T4. We are done executing T1. The next priority level is T2. So T2 is executed. Sorry, it's not drawn to scale, but this is 56. And the last one to be executed here is T3. But remember, T3 needs 12 periods for it to be fully executed. And we just have 4 left. So we just start T3 right now. Does this make sense? I hope the explanation makes sense. Okay, so now we are done with T3. Sorry, we are not done with T3 because T3 needs 12 periods for it to be fully executed. So now, how do we complete it? We have 4 periods right now. How about we just continue? Because if you compare the priority levels between T3 and T1, you see that T3 has a higher priority level than T1. So we're just going to continue executing T3. T3. Then this should be 8. So this should be 68. Yeah, this should be 68. Then now that one that we halted would be executed here. 72. Then we don't have anything left on the queue. This is idle, and then it repeats itself. I hope this explanation makes sense. So the most important thing here are the priority levels. If you know how to calculate the priority values for each of the different types of task scheduling, whether it is earliest deadline first, rate monotonic, whatever name it's called, if you know the formula for calculating it, that is the first thing you calculate here. Once you're done calculating the priority values, you start visualizing it. Now, different people prefer doing this in different methods, but my preference is doing it this way because it helps you visualize all the data that you're trying to compile here, right? So the first thing to do, plot the timeline. Know what the first value is. What is the first or initial delay for that scheduling? What is the highest value? The highest value is typically the highest period of all the tasks. So in this case, it was 80, which is also the LCM of all the periods. So 80 is the largest period here on your timeline. Then you start plotting everything. You have T1 has periods of 20. So at 20 intervals in that timeline, you're plotting T1. You have from 0, 20, you have 60, sorry, you have 40, you have 60, you have 80. You basically do the same thing, no matter what the interval is. If the interval for this one was, let's say, 30, you would start plotting at 30, right? So it doesn't matter. Now, this example kind of like fits perfectly in the sense that they're all on the same timeline. But you could get different timelines for different ones. One thing you need to note about the period is, at that particular period, you need to take account of how that T1, for instance, if you have, if in this case where we had T3 that was getting executed. Sorry, this case where we had T4 that was getting executed, we executed just a small chunk of T4, which was about 16 periods was what was executed here. Now, the reason why we had to halt the execution was because T1 had a higher priority than T4, right? T1's priority was 56, T4's priority was 1/70. Now, because of that higher priority, we are going to preempt T4, then jump to T1. When we are done with T1, we go back to T4. That's another thing that I feel like it's important to note here. But this is the full explanation for conducting task scheduling using earliest deadline first. Thank you.